All right, so in our last section, we looked at compound interest formulas. Today, we're going to be looking at annuity formulas. Go ahead and cross off that first formula sheet if you're using the note sheet. That was the formula that we would use just if you're just depositing something once a year. However, with an annuity is an investment that's made with small deposits made at periodic intervals. So for example, your retirement savings. Most people for their retirement savings put in money every paycheck. So it depends on if you get paid twice a month or once a month or weekly. You may put in a deposit twice a month or once a month or weekly. So pay attention to vocabulary as it will be on the mini quiz. An annuity is a sequence of equal payments made at equal time periods. So for example, maybe you want to put $50 away every month for your retirement. That would be called an annuity. The value of an annuity is the sum of all the deposits plus all of the interest paid. So we have a new formula, a nice big one for the value of an annuity when interest is compounded n times per year. Now in this formula, which will be on your formula sheet, you may want parentheses around the NT and around the R divided by N. If you have a newer graphing calculator, it'll be easier to use. You won't need all those parentheses, but you definitely need the ones in the bottom. So go ahead and add those in. All our variables are the same. A is our future value, P is our present value, rate is our decimal interest rate, and N is the number of times that it compounds. So remember, there's a lot of different values for N. Annually, N would be 1. Semi-annually, N would be 2. Quarterly, N would be 4. Monthly, N would be 12. Daily, N will be 365. And then also I believe you may see this in the mini quiz, weekly. Remember there's 52 weeks in a year, so N would be 52. And then the hardest part about this formula is just typing it in our graphing calculator. Whenever you see these brackets, just realize that those are parentheses, so you're just having like 2 sets of parentheses in the formula. So our first example, if you deposit $2,000 into a retirement plan, that would be our P value, with an annual interest rate of 4%. At the end of each year, for 30 years, find the following. So that means our P is 2,000, our R is 0.04. Now it says we are putting this in at the end of each year, so we're only putting it in once a year, which means N is 1. Time is 30 years. So we're going to use that big formula. Again, we are going to have a set of parentheses around the NT and around the R divided by N. We're going to plug into that formula. So 2,000 times the quantity parenthesis 1 plus 0.04 divided by 1 to the 1 times 30 power. Don't forget this minus 1 that's in the formula. This is one thing I see students miss a lot, and then they get the wrong answer. Now it's up to you. You can type the top part in, get an answer, and the bottom part in, and then divide them. I personally type the whole thing in my calculator, but I also feel comfortable with that. So if you get a little nervous on the graphing calculator, you may want to do the top, the bottom separately, and then divide them. But in the calculator, we'll type in our P value, and then again, do not use the brackets on the calculator. You're putting just a double parenthesis. So 2 open parentheses, 1 plus 0.04 divided by 1. Close the parentheses. Now this is an exponent, so we have to press the caret button. Now the caret button, you really don't need the parentheses if you have the newer calculators that puts them in the little subscript. But if it never hurts you to put them 1 times 30 in parentheses, close them. Now make sure, this is a big mistake I'll see a lot. You have to arrow over to get out of the exponent before you put your minus 1. Now if you want, you can hit enter right now and get an answer in the top and then divide by the denominator. But I just typed the whole thing in, so I'll put a division bar, which is this big thing. And then in the bottom, we do need parentheses for sure. 0.04 divided by 1. And hit enter. Should get 112,169.8 So that's how much you'll have in your account after 30 years if you put it in $2,000 every year for 30 years and accrue interest. Now, it wants to find the interest, which is how much money did you earn? Because you're putting in $2,000 every year for 30 years. So how much of it is from principal and how much of it is from interest? So here's a formula you may want to jot down. This is not on your formula sheet for the mini quiz. To find the interest of an annuity, we'll take our A value minus the total deposited amount. Now, a more specific formula would be A minus, to find the total deposited, we'll take the P value times N, which is the number of times we're depositing it, times T, the number of years. So our A value we found over here was 112,000. We'll plug that in for A. Minus parentheses. Our P was 2,000 every year, so times 1, times 30 years. So really, we deposited $60,000. But at the end of the investment, we had 112,000. So we subtract those two values to find that we earned $52,169.88 in interest. So that's how much extra money you made just by storing your money away until you retired. Next one, very similar, but this one, we are going to deposit only $200 into a retirement plan. The annual interest rate is 6. But this time we're going to deposit it monthly at the end of each month. So we're going to put it in more frequently. So P is 200, R is 6%, 0.06, N is 12, T is 30 this time. So again, same formula. We need our parentheses around there. And we'll substitute in. 200 times 2 sets of parentheses, 1 plus 0.06 divided by 12, to the 12 times 30 power minus 1, close that big parenthesis, and then show your division. So 200, 2 parentheses in our graphing calculator, 1 plus 0.06 divided by 12. Close our parentheses, use your caret button, 12 times 30. Close the parentheses and arrow over to get out of there, exponent spot, then put your minus 1. Close that big parenthesis and divide by the denominator, which is 0.06 divided by 12. And we should get 2,903.01. Again, if you prefer, you could type the top part in the calculator. Like if you're getting an error, sometimes I tell students, type the top part in, type the bottom part in, then take those two numbers and divide them. So 1004.51 divided by 0.005. And you'll get that answer. So if you're struggling with your calculator, you can do the top separately, the bottom separately, and then divide them. Now to find our interest, again, we're going to use the formula, which is to take our future amount minus the amount deposited, which is our P, times the amount of times we're putting it in, 12 times a year, for 30 years. So 200 times 12 times 30 gets us 72,000. And we subtract that from our 200,000 to get, we made $128,903.01 in interest. Example 4, we have a comparison. Same scenario, $300 at the end of each month into an IRA. IRA is for retirement. Interest rate's 3.86% compounded monthly. We're just going to compare different time periods. So what if we only saved for 10 years versus what if we saved for 20 years? So the only thing changing here is our t value. P will stay 300 in both scenarios. R will be 0.0386 in both. N is 12 in both, but t will be different numbers. So in the first one, we're using that same formula and just punching that in our calculator. I suggest you guys all practice on your graphing calculator before you go take the mini quiz, because the majority of students that get these problems wrong is because they can't type the buttons correctly in their calculators. So practice and make sure you know what you're doing before you start that mini quiz. And we should get $43,850.39. Now, for the second part, the only value that's changing is the 10 is becoming a 40. So remember the shortcut on your graphing calculator. You can press second, enter, and that'll recall what you typed, and you can just arrow back in your calculator and change that 10 to a 40 instead of having to type it all back in. You should get 342,437.91. And then our last part is to calculate the interest over 40 years. So we're going to use the 40-year number as our A. And our P was 300, N was 12, and T was 40. Multiply all of those together to get 144,000 and subtract that to find our interest was 198,437.91. So you can see that time is the big difference. If you can save for retirement for a longer period of time, you will earn much more money in interest by doing so. The closure says, how is an annuity different from a compound interest problem? An annuity is depositing money in equal time periods, for example, monthly, quarterly, etc. Whereas a compound interest problem only deposits money once at the beginning of the investment instead of continually depositing. Also, they use different formulas.